Okay, in this video, I'm going to review how to approach the valid-invalid problem section. Of course, all you need to do for this section is to circle an argument if and only if it's valid. So you circle all the valid arguments and you don't circle any of the invalid arguments. But the way you approach the problem is very much like the unpacking section. So if you haven't done the unpacking section, watched that video or worked on those problems, I suggest you do those first. So how do we do this? Well, we want to decide if Kelly wins really is a conclusion from a valid argument from 1 to 4. So how do we do that? Well, we represent the reasoning. Let's let the oldest competitor wins be O, and then say if the oldest competitor wins, then Kelly wins. We'll make that K. And that's our first premise. And now we come down here, and for our second premise, we're going to say if Kelly competes, make that C, then the oldest competitor wins. And we already saw the oldest competitor wins as O, so we've got C then O. And then we come down here to 3, and 3 says if Kelly still has drive, so I'll make that D, then he competes, and he competes with C. So that's P. And now we'll come down here to 4, and we want to make that Kelly still has drive, so that was D. That's a premise. And the question is, can we get to Kelly wins? And Kelly wins is, the question is that a conclusion? And Kelly wins is, what was Kelly wins? It was K. Okay. So the question is, does K follow from these? And you approach it the same way you approach the unpacking ones. You see that D is going to give you C. So I'm just going to say, look, I can draw this conclusion, right? This conclusion C. How did I get that? I got that from 3 and 4. So that came from 3 and 4 by my exponents. And now that I know C, and I'm just going to make D bold, and D gives me C bold to remind myself that I already used them. Now I know C, and I know that C gives me O, so I'm just going to come down here and conclude O. And I got that from little a here and 2. And that was, again, modus ponens, so I'm just going to bold A and bold 2 to remind myself that I used them. Now the only things that are left are O, and O gives me K. So I know O gives me K, so I can get to K. So that is a conclusion. I got that from little b and 1, again, by modus ponens. And since I can get there by using only rules, it's a valid argument. So to indicate that it's a valid argument, I'm just going to come over here and bold the whole shebang, since I can't easily circle it. Okay, so now let's look at the next one. The most valuable member of the team is Saka. So I'm going to just say that's a single proposition, right? So this time I'm just going to go with A first and then do B, C, and so on. So the most valuable member of the team is Saka. I've got if Saka can't throw a boomerang, then he's not the most valuable member of the team. So if he can't throw a boomerang, and we can make that not, since it's saying he can't, then he's not the most valuable member of the team, and he was A, so that's going to be not A. And just bring that back this way. So I've got if he's not the most valuable member of the team, then it's not the case that he can throw, if he can't throw a boomerang, then it's not the case that he's the most valuable. That's a premise. Then come down here to 3, and 3 says if Saka can't throw a boomerang, and we just saw that was not B, then he has a space sword, and that's new, so we'll make that C. That's a premise. Another question is, can we conclude that Saka has a space sword? And that's 4. So has a space sword with C, and the question is, does that follow? And let's look at it. We know A. We know if B is false, then A must be false. But we know A is true. Well, if B is false, then A must be false, but A is true, which means B can't be false. And put another way, that means B must be true. So I'm just going to come over here and note that I've now learned that B is true as a conclusion from 1 to 2 by modus tollens this time. Let's move that over so it stays up here. Just make everything smaller so it fits better. Okay, so I now have B as a conclusion, and I've just used 1 here, so I'm not going to look at that anymore, and I've used 2, so I'm not going to look at that anymore. And I know B, and I know that if B is wrong, then C must be right. Sorry, if B is right, then C must be right, because that's can program right. So if B is right, then C must be right. So B then C, I know B, which means I can conclude C. So C is going to be a conclusion from little a and 3, this time by modus ponens. So that does follow, so this argument is valid, so I can bold the whole thing. Now, let's come back over here. I'm going to make this bigger again. Either pixies aren't real or ducks can fly. So I'll say ducks can fly or pixies are real. That's a premise. And then I come down here to 2. It says ducks can fly. So that's A. And then my conclusion is 3, which is if pixies aren't real, then I guess that's another premise. If pixies aren't real, then I've never seen one. So if not pixies are real, then not I've seen one. And then the question is, can I conclude that I've never seen a pixie? Well, I know A, and the first thing to see is, can A tell me anything? And you might be tempted to think it can. You might be tempted to think, since I know A or B, and I know A, I know it can't be B. But that would work only if the or here was the exclusive or. But remember, we're always going to assume or is inclusive unless I give you context that clearly shows that it's exclusive. Okay, so unless I give you context that clearly shows that it's exclusive, assume or is inclusive. And since we're assuming or is inclusive, the fact that we know at least one of these is true and we know this one is true doesn't tell us anything about this one, because A or B, when it's inclusive, means A or B or even both. So when I learn that A is right, that doesn't tell me that B is wrong. Maybe B is still right. So because of that, I can't infer that B is wrong. And because I can't infer that B is wrong, I can't use this here to get to not C. So there's actually no way to get here. So this argument here is invalid. And often invalid arguments in these kinds of problems will work that way. There'll be some little move such that if you make a mistake, like you assume the or is exclusive, you could get to the conclusion. And that's how, the reason it's like that is because bad reasoning that tricks people is often like that. There's some little trick such that if you fall for the trick, it'll look like good reasoning. Okay, let's look at the next one. Most dogs have fur. I'm just going to move this over again so we have more room. Most dogs have fur. Call that A. If most dogs are animals, then most dogs have fur. So it's saying if B, then A. Now 3 says if most dogs are mammals, so that's B again. Then most dogs give birth to live young. We'll call that C. And the question is, can we get to the conclusion that most dogs give birth to live young? So does that follow? And these, of course, were all premises. So you can't, in fact, this one here again is invalid. So I'm just going to type invalid so you know it's invalid. But it can trick some people. And the way it tricks people is this. We know that A is true. We know that B tells us we know that B would tell us that A is true if B were true. So since we know A is true, and we know that B implies A, it's tempting to infer that B is true. And if you infer that B is true, you can then use that and B, then C to get to C. But the fact that A is true and the fact that B implies A doesn't let you conclude that B is true. Just like the fact that X is a sister, and the fact that if X is a sister, the fact that X is a sibling, and the fact that if X is a sister, then X is a sibling, doesn't let you infer that X is in fact a sister, because X could be a brother. So this form of argument, if B then A, therefore B, is invalid, but that is the form on which this argument rests. So this one's invalid. So let's look at the next one. If Zuku knows Aang, then Aang always seeks a peaceful solution. So if Zuku knows Aang, then Aang always seeks a peaceful solution. Zuku doesn't know Aang, so it's not the case that Zuku knows Aang. Then we have if Aang doesn't always seek a peaceful solution, so it's not the case that Aang always seeks a peaceful solution. Then, that would be not B, because B seeks a peaceful solution. If Aang doesn't always seek a peaceful solution, then Aang sometimes fights too much. We'll call that C. And the question is, can we get to the conclusion, number 4 here, that Aang sometimes fights too much? So does that follow? Well, we know A is wrong. We know if A is right, then B is true. And it can be tempting to use these to infer that B is wrong. Then you could go from B is wrong, then C, to conclude C. But that's also an invalid inference. So if we did that, we'd be wrong. So this argument 2, I'll just type it over here, is invalid. So why is it invalid? Because the fact that A is false and the fact that A implies B does not tell you that B is false. So consider an example. If Dana is a sister, then Dana is a sibling. But Dana is not a sister, therefore Dana is not a sibling. That doesn't follow because Dana could be a brother. So this argument 2 is invalid, and we can move on to the next one. If Romney will win the next debate, then Obama will not win the popular vote. So this is going to be, if Romney will win the next debate, then Obama will not win the popular vote. And then we have, if Obama will not win the popular vote, so that's going to be, let's go back here and make not win the popular vote, not B, to make it easier to keep track of. So not B, then what follows? Romney will win the popular vote. So that's Romney will win the popular vote. And now we have, as our next claim, if Obama will win the electoral vote. So did that occur before? Obama popular vote, Obama popular vote, nope, so it's going to be a new letter. Obama will win the electoral vote. Then what's going to happen? Romney will win the popular vote. And Romney will win the popular vote was right there, so that's C. So if D, then C, that's a premise. And now we come down to the next one, Romney will win the debate. And let's look back up to see where we had Romney will win the debate. That was the very first thing, so that's A. And the question is, does it follow from all that that Obama will win the electoral vote? And Obama will win the electoral vote was D, so does D follow? We have A, right? And we have A gives us not B. So we can draw a conclusion. We can conclude that B is wrong because we know A and we know A tells us B is wrong. So that's a conclusion from 4 and 1. And I'm just going to bold 1 and bold 4 to remind myself that I've used them. Now I have that B is wrong. Well, I know B being wrong tells me C is true. So I'm going to conclude that C is true because I know here B is wrong. And I know here that B being wrong tells me C is true. And that was a conclusion from my little a and number 2. And now I know that C is true. And the question is, can I get to D from what's left from these two, from B and 3? Well, this tells me D gives me C, but it doesn't tell me that C gives me D. But the person who says, look, D gives you C, C, therefore D, acts as if D gives you C is the same as C gives you D, but it's not. So the fact that D gives you C and the fact that C is true doesn't allow you to get to D. So this argument is invalid. A lot of times people fall for or get tricked by invalid arguments when there's a bunch of valid moves on the way there. So in this case, there were a couple of valid inferences, right? We drew these two little conclusions over here. They were good inferences. But the argument as a whole is invalid because you then have an invalid inference to get to 5. Okay, next one. I'm just going to quickly move this over so that we have a little more space to work on the side there. Do the same here. Okay, so number 1 here, if you mostly circle valid arguments in the practice problems, if A, then you'll mostly circle valid arguments on the exam, B. That's a premise. Oops. Now you get to number 2 here. If you mostly circle valid arguments on the practice exam, that was B, then you'll do well on this section of the exam. That's a new one. Let's see. And come down here. It says you won't mostly circle valid arguments on the practice exam, so it's saying the practice exam is not going to go as well as you'd hoped. That's a premise. And the question is, does it follow that you won't do well on the actual exam? And I'll, just to prefigure, tell you this is invalid. Why is it invalid? Well, basically because the fact that you didn't do well on the practice exam doesn't ensure that you won't do well on the actual exam, even if the fact that you do well on the practice exam would ensure that you would do well on the actual exam. So let's look at this. Here we have, if you do well on the practice exam, then you do well on the actual exam. And down here we have, you don't do well on the practice exam. From that, it does not follow that you won't do well on the actual exam, because maybe you could do well on the actual exam even though you didn't do well on the practice exam. So, and that's true even if doing well on the practice exam guarantees doing well on the actual exam. So not A combined with A then B does not give you not B. And since you don't have not B, there's no way to get to not C. And even if you had not B, there wouldn't be a way to get to not C, because not B combined with if B then C doesn't give you not C. In each case, you're engaged in fallacious reasoning. Your argument would rest on a logical error. Okay, 2 more here. Let's do this one. Number 1, if you have 10 fingers, then you have at least 9 fingers. It's a premise. Number 2, if you have 10 toes, that's new because it's toes rather than fingers, then you have at least 9 toes. That's a premise. Number 3, either you have 10 fingers, that was A, or you have 10 toes, that was B. It's a premise. So the question is, does it follow that either you have at least 9 fingers or you have at least 9 toes? So does that conclusion follow? Oh, this one was A or C, right? Either you have not 10 fingers or you have 10 toes. 10 toes was C. All right, so we know A gives us B, we know C gives us D, and we know A or C. Well, the fact that A or C means either this one is right or this one is right. If it's this one, you're going to get B. If it's that one, you're going to get D, which means you've got to get either this one or this one. And that's what the conclusion is. So indeed, this conclusion does follow. It's a conclusion from 1 to 3 by constructive dilemma. So this is another case of a valid argument. Finally, if I'm a person, therefore I'm a person. This argument has the following form. A, therefore A. And the question is, does that conclusion follow? And the answer is that it does. It's a conclusion from 1. Why? Because you know you're guaranteed that if A is true, then A is true. So it's a very simple form of valid argument. Okay, and that's all the problems on from the practice problems on the valid and invalid section.